Okay, good afternoon.
Good afternoon, teacher.
Good afternoon, teacher.
How are you?
Good afternoon.
Fine, how are you?
Fine, how are
Fine. How are you?
I'm fine. How did you feel
Fine.
find the calculus? How did you find the calculus?
teacher turn now? يعني a little bit easy.
It is a
Yeah, it's easier now than algebra. Yeah. Okay. Today now we will talk about the infinite limits. In the previous here, in the previous section, we said that if we have to find the limit of any point when x approaches to this point, to this exactly point, and the answer is a point, like as an example here. If we have a 3, the limit of x of when x approaches 3 from the right, we say that we look at the right side and we say that the answer is 3. So here we talk about limits when x approaches to point and the answer is point. But here now, today, we are talking about that the limits here is not a finite number, is not 4, is not I say limit of x when x approaches 2, the answer is 4. No, here we have an infinite limit. The answer, it will be positive or negative infinity. Now, as you see here, limit x when x is approaches to our limit 1 of x when x approaches 0 from the right. What is 0? Here is 0. Now 0 from the right, I mean here. Now look at this limit here. In this limit, it increases. Okay, and does it increase to the positive x-axis or to the y-axis, to the negative wait, sorry, to the positive y-axis or to the negative y-axis? The limit, I'm talking about the value of x. So I'm looking only to the positive x, positive y, or negative y. Just to know that if it is positive infinity or negative infinity, just you have to look at y-axis, positive or negative. Let's start with the first one here. In the first one, as you see here now, of 0 of 1 of x when x approaches 0 from the right. Look here, the infinite limit. It's going to be to the positive x or negative x. And positive, ya Allah, positive y or negative y? Positive y. Is it right? The values increased in the positive y. Because of that, I will say that it is positive infinity. But if you look at limit 1 over x, when x approaches 0, but now from the left, here we have 0. 0 from the left, I mean here. Now, since it doesn't touch the x-axis, I will not say a point. It makes the x-axis like asymptotes. So because of that, I will say that since the curve will not, please girls mute the microphone. Now, since here the point of our limit when x approaches 0 is not at exactly point. When it is at exactly point, I will say that the answer is 3 or negative 3. But here it goes need to be near the y-axis, but it doesn't touch it. That's why I will use positive or negative infinity. I will repeat. Here the curve or the line, it touch the x-axis or the y-axis at exactly one point. But here, it doesn't touch it. It's got to be close to the x-axis, but without touch it. So, because of that, here, when I ask you about 1 of x at 0 from the right, and the curve now will increase without bound, will increase to the positive y-axis, I will say it is positive infinity. But in the 0, but from the left now. At 0 from the left, the curve now. Look at the curve in the y-axis, not on the x-axis. Look at it only in the y-axis. And the 0 from the left, on the y-axis, the curve is got closer to the negative y-axis. Negative y-axis. That's mean
Can
negative
you let
infinity.
Lana in?
Okay. Back. Are you still seeing the slides? Is it right?
Yes, teacher, we can see them.
Okay. Let's continue now. So, here, as we said that if we have now, if we have now these curves and the difference between the infinite limits and the infinite limits, that the previous one, the finite limits, it touched the curve at exactly one point. It could intercept the x-axis or the y-axis or intercept any point. But in the infinite limits, here, no, it cannot touch it. It just moves near to it, like the asymptotes. Do you remember the asymptotes that we were talking about in grade 10? When we say that if we have the asymptotes at x equal to, the curves will go on to be, but without touching it. Here we have the same. The curve, it's like it's put the x-axis at its asymptotes. So it's go, but without touching it. So because of that, this type of limits, we called it infinite limits. How to find it? I will repeat. Y is equal 1 over x. When x approaches 0 from the right, just look at the y-axis. When 0 from the right, it's going to be to the positive y-axis. That's mean positive infinity, as you see here. But in the 0 from the left, if you are looking now to this side here, it goes to the negative y-axis. Negative y-axis, that's mean negative infinity. Not every time according to the graph, as we see here. I mean, not every 0 positive, 0 positive infinity, or 0 from the left, negative infinity. No, according to the graph that I'm talking about it. Now, look at this book, this example here. In this function here, I want now to find limit 1 over x minus a when x approaches a from the right. Where is a? Here is a. Look here now, the vertical asymptote is not the x-axis or the y-axis as we saw before. We have now at this here we have now the vertical asymptotes. It is at point A. Now, at point A now, as you see, it is the red line. At point A from the right, look at A from the right. Where's the curve gonna be? It's gonna be to the positive y-axis. So it will be positive infinity. Now, limit 1 over x minus a when x approaches a, but now from the left. Here we have 0 a from the left. The curve will go to the negative y-axis. That's why it's equal to negative infinity. Now, is the limits of x approaches a from the right equal x approaches a from the left? No. So because of that, I will say that limit 1 over x minus a when x approaches a is not exist.
Teacher,
Yes, Salah.
we know it because of the drawing, the arrow.
Yes. In this lesson, yes, from the drawing only.
تمام.
Teacher,
What lesson
Yes.
is this?
Can you repeat?
What lesson is this?
Lesson number 1.
Okay. Thank you.
teacher, can you repeat why it doesn't exist?
Because when limit of 1 or when limit when x approaches a from the right, it's equal to positive infinity. And when x approaches to a from the left, it's equal negative infinity. Is positive infinity as equal to negative infinity?
No.
No. That's why it's not exist.
Okay.
Now, let's go to the B, figure B. Look at figure B here. If I want now to find limit of 1 over x minus a squared when x approaches a from the right. Look at a, but from the right now. Where's the value of y-axis? It's go. Does it go to the positive x-axis or to the negative x-axis?
To the positive.
The positive y-axis. To the positive y-axis. So that's mean it is positive infinity. Now look at limit 1 over x minus a squared. But now when x approaches a from the left, here we have a from the left. It's gonna alter to the positive y-axis, so it will be positive infinity. Since now in the right is equal to the left, so I can say now that limit 1 over x minus a squared when x approaches a is equal to infinity. Because they are equal, so I will choose one of them. Yes?
Miss, why in the second one it's positive infinity? Why it's not negative?
Here?
The second one.
No, don't look at C. I'm only in B now.
No, I mean limit 1 over x minus a squared when x approaches to a.
Okay, look at A from the left. Where's the value of it? It is this yellow, the yellow curve. This yellow curve. Where it's gonna? Where it's going? It's
Yes.
going to the positive x-axis or negative x-axis?
Yes, positive.
Thank you. Yes. Okay. Now let's do C. So, but before that, since now from the right is equal to positive infinity and from the left is equal also to positive infinity, so I can say that limit 1 over x minus a when it approaches a is positive infinity. Let's do now C. In C now, limit negative 1 over x minus a when x approaches A from the right now. Here, when x, I want now to talk about the second graph. When x, this one, but when x approaches A from the right, here we have A from the right. So the values are going to the negative y-axis. As you see here, here we have negative y-axis. So because of that, I will say that the answer is negative infinity. Why negative infinity? Because it's going to the negative y-axis. Now look at the second one. Limit 1 and negative 1 over x minus a, but when x now approaches to a from the left, sorry. Look at a from the left now. What about the values of a from the left? It goes to the positive y-axis. So it will be positive infinity. Does it equal? No. So because of that, I can say that limit negative 1 over x minus a when x approaches a is not exist. Let's now do figure number D. Oh, let D, yes. In D here, if you have limit negative 1 over x minus a squared, but when x approaches a, but now from the right, look here at the right, what's the value of y? It goes to the negative y-axis. Yes, thank you. So because of that, the answer is negative infinity. And limit negative 1 over x minus a when x but now approaches to a from the left, as you see here, it goes also to negative infinity. So the answer now is negative infinity. Does it equal? Yes. So because of that, I can say that now limit when negative 1 over x minus a when x approaches to a is equal to infinity. Is it clear?
Yes, teacher.
Yes, teacher.
مس
Yes.
Yes, Lana.
بس عندي سؤال.
Yeah.
بس كيف حددتي إنه هي رايحة على النيجاتيف سايد مو البوزيتيف؟
Look at the curve here. Does it go to the positive y-axis or negative y-axis? Just look at the values of y. As I told you, limit, it's like function. Just at the values of y.
Okay.
Yes, to the negative. Now, let's do exercise number 7. Here, I want you now to find limit f of x when x approaches 3 from the left. Where's the 3? Here is the 3, as you see. Now, 3 from the left. Look at 3 from the left. The first question I have to ask myself about it. Is it exactly at one point or close to point, or it is an infinite limit? Look at it, the 3, but from the left now. Does it at exactly one point, or the curve will not stop?
It will not stop.
Yes. So because of that, I ask myself, is it go to the positive y-axis or negative y-axis?
Negative.
The negative y-axis.
Thank you. Because it's go to the negative y-axis, I say it is negative infinity. Let's see now limit f of x when x approaches 3, but now from the right. Where's the 3 from the right? Is it here?
Also negative?
Yes, thank you. It goes to the negative y-axis, so it is negative infinity. So here, now, then he asked me now, limit f of x when x approaches to 3. Does it equal in the left
Yes.
with the right? Yes.
Yes,
So I will
exists.
say negative infinity. Yes. So I will say that limit f of x when x approaches 3 is equal to negative infinity. And is it existed? What about now f of 3? Look at f of 3 here. Did we have a black or a closed point of 3?
Yes.
Yes.
Yes, at point what?
1, 3.
What is the value of
At
that?
point 1, 3.
1. 1. Right, look here, 3, and its value is 1. So f of 3 now is equal to 1. Let's now look at exercise number 4. In exercise number 4 here, as we see, here we have to find limit f of x when x approaches to 2 from the left now. Where is 2? Here is 2, as we see. Now, where is 2 from the left? Who can tell me?
Can I teach it?
Yes, Hannah.
To the positive.
Positive what?
Positive of y.
Does it? No, see here. If it is like this, and comes like this, you will say that it's positive y-axis, but it is touch the asymptotes. If you here draw a line, does it touch it?
Yes.
Yes, because it touch it, so I will not say, I will make it like this. Does it touch it? Yes,
Yes.
because it touch it, I will not say to the positive y-axis. Here, it's not touch it. It's like, it's gonna be like asymptotes. So I will say to the positive y. But here, it's touched the line. It's touched the line at point positive 2, as you see here.
Teacher,
Yes.
Miss, I still didn't understand why it's positive 2, not positive infinity.
And for the positive infinity, the graph is like this. Here we have 2, and it's like this, and like this as an example. Okay, so the curve here, if you draw a line, that this line is intersect 2. At this point, does the curve, the blue curve, intersect this line? Does it intersect it? No.
No.
So because of that, I will say that it's going to be to the positive infinity. But here now, but here now, in this graph here, it comes like this. Okay, so it starts from point. If you draw now a line on it, this point, it's intersect the 2, or the line of 2. because it's intersected, so I will say that the answer is positive 2. Now, look at the 2 from the right now. Now look at the 2 from the right here. It's like this. So, limit of 2 from the right. Does it, if you draw now this line, does it, is it touch the line? Yes,
Yes.
it's touch it.
Yes.
So what is the value of y here?
2.
2, if I'm talking about the left. I'm talking about the
0?
right now. 0, thank you.
Teacher, I'm confused.
Now, with infinite and the numbers?
No, I'm confused why it's 0, not 2.
Okay. Now, look at number 2 here. Look at the 2 from the left. Okay? I want you now to put your hand in this side. In this circle, put your hand in, please. After you put your hand, look at number 2. From the left, the curve are coming from any place and stop at point what? At which point does it stop?
Positive 2.
Positive 2. So I will say that limit when x approaches 2 from the left is positive 2. Okay, now. Now, I want you now to do the same, but I want you now to put your hand in this side and look now at the 2. But now from the right. Here. The curve are coming and stop at which point?
You mean the point, the white one?
Yes. Where does it stop? It comes from, then at stop at
0?
0.
On
Yes.
the x-axis? And teacher,
Yes.
we use the x-axis to know the answer?
No, y-axis. Y-axis.
Why? Oh, okay, yeah. Okay.
Here it's, the coordinates here is 2, 0.
Yes, okay. Yeah.
I'm talking about limits. I told you, f of x, it's mean y. And
Yeah.
f of x, sometimes it's mean limit. So like so because of y is the same as f of x, and f of x the same as limit, so y is the same as limit. So limit, it's mean the value of y.
Okay, thank you.
You're welcome. Go to see now. Limit f of x when x approaches 2. Here we said it is 2. And to the right it is 0. Does it equal? No. So
No.
because of that, I will say that limit f of x when x approaches 2 is not
exist.
Why? Because limit f of x when x approaches 2 from the right is not equal limit f of x when x approaches 2 from the left. Now the last one, f of 2. What is 2 here? I will look at 2. I draw a line. I will search about a black point, a colored point. So f of 2 at the y-axis here. What is the value of x in the y-axis? Equal to 2. Yes, thank you. Do you have any question?
No, miss, thank you.